In part one of this course on motor grader operation, we covered a series of daily checks you should make before you take the grader out of the yard. Now in part two, we'll look at positioning the blade for different kinds of work and maneuvering the grader. Let's start with blade positions. As I said in part one, the grader is a versatile machine. It has to be. It's used to do a wide variety of maintenance tasks. From grading shoulders to plowing snow, from cleaning ditches to mixing asphalt, and the list goes on. The critical factor in all these operations is blade position. You can choose from an infinite number of blade angles and heights to meet the demands of any grader operation. But there's more to it than just knowing what blade settings should work. You have to develop a feel for the grader and its controls. Successful operation of a motor grader depends on the instincts and split-second reactions of the operator. Now, we can't teach instinct. That comes only through experience. But we can show a few of the possible blade settings and explain how they're used on some common maintenance activities. There are 5 blade movements: blade lift, circle rotation, blade pitch, blade side shift, and circle side shift. All grader operations require a combination of some or all of these basic movements. The hydraulic controls in the cab of the grader direct each of these movements. But as you'd expect, the controls vary from one model of motor grader to the next. So we'll concentrate on the movements, not the controls. The first movement is blade lift. You can raise and lower the entire mold board or just one end at a time. For example, if you wanted to level an area, you'd probably set both ends of the blade at the same height. On the other hand, you'd set one end of the blade slightly higher than the other end if you wanted the surface to have a crown or slope. When you lower the blade until it barely touches the surface, you have a loose blade. That's one of the 2 basic operating heights. The other is a tight blade. That's when you put enough downward pressure on the blade to dig down into the surface. A loose blade works best when the job calls for spreading or mixing loose material. As you can see here, the blade picks up only the loose material on the surface without damaging the pavement underneath. A tight blade is used when you need to reshape the surface by cutting into it. However, most jobs require a combination of a loose and tight blade. Generally, you'd set the toe or leading end of the blade slightly tighter than the heel or trailing end. This works well when you're cutting and windrowing material. The second blade movement is circle rotation. The blade is attached to a circular mechanism mounted on the grader's frame. By rotating the circle clockwise or counterclockwise, you can achieve any blade angle through a range of 360 degrees. When the blade is straight across the frame, it's at the 0 degree or spreading angle. All other blade angles are measured from this position. As the name suggests, the spreading angle is used for spreading material. The blade pushes the material forward with a dozing action. the material spreads to both ends of the blade, leaving little or no windrow on either side. Now, as you rotate the circle, you change the blade angle. Most jobs require a blade angle somewhere between 15 and 45 degrees. When you increase the blade angle, you increase its ability to windrow rather than spread material. The general rule is to use a sharper blade angle to make a larger windrow. The blade angle also affects the placement of the windrow. In most cases, you want to set the angle to place the windrow either outside or inside the rear wheels. What you don't want is to have the rear wheels riding on the windrow. That reduces traction, and the up and down movement of the grader will make your cuts uneven. One more point about circle rotation. A change in blade angle often results in a change in blade height. As you rotate the circle, one end of the blade goes down as the other end rises. So after you change the blade angle, you may also have to adjust the blade height to get the position you need for the job. Now the third movement, blade pitch. Blade pitch is the vertical angle of the mold board. You can pitch the blade forward, backward, or leave it in the upright position. A forward pitch gives the blade a dragging action, and a backward pitch gives it a cutting action. For example, this operator has his blade pitched slightly forward. By applying only slight downward pressure on the blade, he can drag and smooth the surface without cutting into it. Here's another example. Blade mixing asphalt. Notice how the forward pitch rolls the material off the mold board. That helps mix the material. The forward pitch also provides compaction. It kind of squeezes the material together for better mixing. So for dragging or smoothing the surface, or for mixing and compacting material, use a forward pitch. But for cutting or reshaping the surface, use a backward pitch. In this position, the cutting edge of the blade is up front. By applying downward pressure on the blade, you can dig into the surface instead of just dragging it. But the material will lift and pile up in front of the mold board, and it won't roll off very easily. You lose the mixing and compacting action you get with a forward pitch. So for most operations, pitch the blade upright or slightly forward. That gives you both the mixing and cutting action most jobs call for. Okay, that's blade pitch. Now, blade side shift. The purpose of blade side shift is to extend the reach of the grader. You can shift the blade to the left or right. Side shift is a handy feature when the work is hard to get to. It lets you keep the grader on a level, stable surface because you can extend the blade to reach the work area. You can also use blade side shift as a safety device for working on slopes. By extending the blade to the downhill side of the grader, you can use it as a prop to keep the grader from rolling over. The fifth and final movement is circle side shift. Circle side shift accomplishes the same thing as blade side shift. It extends the reach of the grader. The difference is that in blade side shift, only the blade moves. But in circle side shift, you can move the entire circle from one side of the grader to the other. That not only extends the reach of the grader, it also makes it easier to position the blade for certain types of work. Here's what I mean. To reach the back slope of this ditch, the operator has shifted the circle to the right side of the grader. After that, he's able to lift or lower the blade and change the blade angle and pitch while he's in the ditch. Without circle side shift, there's no way he could position the blade in such tight quarters. Let's quickly review the 5 movements. Blade lift, circle rotation, blade pitch, blade side shift, and circle side shift. All motor grader operations involve a combination of these 5 basic movements. But it's impossible to assign a specific blade setting for any particular job. What was seen here are guidelines. You'll have to experiment with different blade positions on the job to see which setting works best. Now let's look at maneuvering the grader. Before you leave the yard, you have to position the blade for travel. Here's how it's done. Lift the moldboard and rotate the circle until the heel of the blade is in front of the left tandem tire. The toe of the blade tucks in behind the right front tire. Not too close, though. You don't want the blade to hit the tire when you turn. The point is this: try to keep the moldboard within the width of the grader. However, if the moldboard is too long, extend it out to the right side so it won't interfere with traffic. For the most part, driving the grader on the road is about the same as driving any piece of equipment. And the same rules apply. For example, if your grader has rollover protection, wear your seatbelt. Always travel at a speed that's consistent with the road, the traffic, and the weather conditions. Upshift and downshift the transmission 1 gear at a time. And stay in gear. Never coast in neutral. Slow down well in advance of intersections and turns. The grader is a heavy machine, and once it gets rolling, it needs plenty of time and distance to slow down and stop. Okay, nothing new there, but graders have a couple of moves that you might not be familiar with. The first is front wheel lean. There's a control in the cab that lets you lean the front wheels to the right or to the left. You can use front wheel lean to help you get the grader through sharp turns. Here's what I mean. Watch how the operator takes this turn using normal steering. To make the turn, he has to cross into the opposing traffic lane, and that can be dangerous. Now watch him make the same turn using front wheel lean. As he enters the turn, he leans his front wheels in the direction of the turn, and at the same time, he turns the steering wheel. As a result, he's able to stay in his lane and make the turn safely. One more point. After you go through a turn using wheel lean, return the wheels to their normal vertical position. If you don't, the grader will drift in the direction the wheels are leaned. You could end up driving off the road and into a ditch. Articulation, or frame steering, provides additional help in turning. By articulating the frame, you can cut down on the amount of room you need to turn. The thing to remember here is, always check the position of the blade before you articulate the grader. If the blade comes in contact with the rear wheels, you'll be replacing a lot of tires. You'll use wheel lean and frame steering to maneuver the grader on the job as well as on the road. For example, when you're windrowing material, the weight of the material pushing against the toe of the blade pulls the grader in that direction. You can counteract that pulling force by leaning the front wheels in the direction you're moving the material. That helps you keep the grader going in a straight line. And when you're pulling a ditch or working on a slope, use frame steering. It lets you keep the rear wheels on stable ground while the front wheels ride on less stable or uneven ground. That lessens the up and down movement of the blade caused by the variations of the surface, and you get a better cut. As I said before, exactly how you position the grader and set the blade is determined by many factors. But for most types of work, the normal operating position of the grader should be like this. The frame of the machine in a nearly straight position so that the front and back wheels follow almost the same path. The front wheels leaned 10 to 15 degrees in the direction that you're moving the material. And the blade pitched slightly forward and angled between 15 and 45 degrees to cut and windrow material. Okay, that's it for part 2. In part 3, we'll take a look at some variations of this position as we discuss operating the grader on some of the more common maintenance activities. This is part 3 of motor grader operation. In this program, we'll look at operating techniques in actual work situations. But first, let's go over 6 basic steps of motor grader operation. Steps that you'll follow on just about all grading jobs. Step number 1, study the area. Picture in your mind what needs to be done on the first pass and the following passes. It's even a good idea to get out and walk the job before you begin working. Look for washouts, holes, and anything else that could interfere with the operation. And note the location of underground utilities or low-hanging tree limbs and power lines. Okay, step number 2, position the grader. Exactly how you line up the grader depends on the job, but most often you'll put the grader directly in front of the work or just off to the side. Now the third step, set the blade. Adjust the height, angle, and pitch of the mold board. And if necessary, side shift the blade or circle so you can reach the work area more easily. The fourth step, select a transmission gear that will carry you through the pass without lugging or overloading the engine. Use a low gear for harder cuts and heavy material, and use a higher gear for lighter loads. All right, the fifth step. Drive straight ahead using front wheel lean, frame steering, or both to keep the grader from side drifting. And finally, the sixth step. Once you get going, make as few changes on the blade setting as possible. Constantly adjusting the blade on a working pass will make your cuts uneven. Try to get it right the first time. So for most operations, first, look at the work ahead. Second, position the grader in front of the work or off to the side. Third, adjust the blade. Fourth, select a transmission gear suitable for the job.